Okay, I'm writing a test suite. For this. Two constants compare equal, even if they are not equal. Unless you tell it that they do not compare equal. Then this is less than that, as usual. Two symbols compare by ID, so the 0 is less than 1. Yeah, what should I tell test next, right? Well, I think just have a lot of types and a lot of tests. I did compare constant with a constant, but I should have that the constant, any constant, is less than anything else. Might as well use the lowest one then. And then, yeah, for every type, right? So I'm trying to use the lowest possible type. This must be less than that one. Did already compare that actually. A constant must be less than a symbol. Oh no, I'm testing that right now, like here. Okay, so power product exponentiation. No, let's do, yeah. The order is kind of added in a comment. Yeah. This gives me the order in which things should be apart from constants ordered. We should keep that handy here. So I defined symbols, and now I need to find a power. Well, that would be this one. Get the non-constant factor of product. That is then symbol 0 here. Exponentiation. Okay, exponentiation. An exponentiation is something to the power of some constant. I'll just use this constant. Where the something is cannot be a product type. That is not a constant, not a symbol, not a power, not a product. Could be another exponentiation. It's an interesting question, actually. No, that cannot. That would be recursive, so that doesn't really help me much. I mean, not at the moment. Let's go for multiplication then. But yeah, the thing has the same problem actually. The multiplication is something times something else, where the first thing cannot be a multiplication, but also not a symbol, a power. Actually, it can be. The first thing can be anything, but then the second thing, I mean, the combination of the two cannot be both product types, which means again that it must be something beyond this point. So I either need an exponentiation, which I don't have yet, or I need a multiplication, which I don't have yet. I could use a sign, I guess. The lowest, so even less than a sum. So let's call this 0. The lowest sign that I can think of is the sign of symbol 0. The sign of a constant would be a constant. So and then I can use that here to escape that it is not allowed to use whatever else, and then we can use a constant here, which would be definitely the lowest type without recursiveness. And then exponentiation could use, well, actually the exponentiation is less than multiplication, so maybe I should use this one first and then use a sign here. No, that's nonsense. For the exponentiation I want to use a multiplication. So now I have a multiplication and an exponentiation. Still need a sign of a cosine. Let's say the cosine of symbol 0. And a sum. Now then again, I think I am allowed to add a constant, but I cannot allow to add two constants. That would be a constant again and not a sum. So the lowest possible thing here is a symbol. I could add a constant with the symbol. Lowest symbol. This would be the lowest possible sum, which I then call, yeah, I think I used C for constant before, so let's call it C1. Constant, sorry, C0. And then a constant must be comparing less with all types. So we have symbol, power 0, product, sign, but let's start with the next thing here. That would be an exponentiation. Exponentiation, multiplication, sign, sum, something like that. What did I say? Exponentiation. Then we get multiplication. And then we get a sine and a cosine and a sum. I'll show what compare less is. It's doing a lot of stuff actually. Compare less is this function where we're passing compare constants either way. It means that they both compare equal as well as not equal. Both tests are performed. And then I'm testing less than with the first argument first and with the second argument first. So it's quite involved. There's a lot of tests. Oh, it failed. Expected constant to be less than symbol. Well, that's correct. A constant should be less than anything. When constants do not compare equal. Well, that doesn't really matter. The value 0 here gives me the indication of which symbol, which is less sum is being used. So it means that this one was being used, but that's kind of trivial because that's the false type. So it failed to return true while it should have been returning true. Then it's always using this. But it should have been using, by comment, this one. A constant is less than a non-constant. So why did it not use this one? Probably because I'm having true here. Why do I have true here? The true here means that constants compare equal. So I did not define this one for when they do not compare equal, which is wrong, right? I mean, a constant is always less than a symbol, independent of whether two constants themselves compare equal or not. So this should be anything, really. And now it works. Cool. Yeah, so note that this test also tests when I have them swapped. So I also test that symbol 0 is not less than the constant. Therefore, I'm now done with constants. So we get constant with symbol and the rest, but now I get symbol with everything below that, and then power with everything below that. So it gets the list gets shorter and shorter. So next I want to test comparing symbols as first argument. So I can say that a symbol compares less than anything else, but not, except constants, of course, but that's trivial. So except other symbols that are less that, well, that have a smaller ID, including products of a constant with such symbol. Product, including a product. Okay, so now we can do the test. So we say that symbol 0 compares less than symbol 1, which then automatically also tests that symbol 1 does not compare less than symbol 0, right? Otherwise I should do equal. Yeah. And symbol 0 also tests less than, well, what's the next one? Power 0. And it tests less than a product, but only if that product is again either an arbitrary product or a constant times symbol 1. Yeah, so oops. So I explicitly should test that they compare equal should I test that two equal symbols test equal? Probably. Let me do that first then. Symbol twice the same symbol compare equal, obviously. But the symbol 0 also tests equal with a product of a constant times symbol 0. I think. Yeah. But it compares less than a product that does not start with a constant. I don't even have that. So something that is not a constant. 0, 1. So why do I need to compare with 3 products? Well, because if the product starts with a constant, we're actually comparing it with the second argument. And then I want to compare the equal again, and then that it is less than if that is a 1. And then, yeah, the general case where it's just a product that does not start with a constant, must be less than. So it also compares less than an exponentiation. Yeah, that's any exponentiation. The power here is defined as symbol 0. Okay. And then again 3 for the multiplication. So I want multiplication C1. That would be less. But not, sorry, that's the other way around. No. This one should be equal. And those two should be less. I need to define that then. Let's see, which am I using? I'm just moving down what I'm not using yet. Symbol 0, we have that. 1, power, we have that. I'm not using power 1. Okay. Product C0 is new. No, we already had product C0 or not. Yep, up there. Product C1 is new. I don't have the D. No idea why I call it D. Not using these. So, not using the sum. Well, I'm going to use sum, right? I have to compare with the sum. I already have a sum. Yeah. Multiplication. So what comes after multiplication? Then we have the sign. So this is less complicated. Just the product and multiplication are slightly complicated, but for the rest it just all compares less. Symbol compared less than a sine, less than a cosine, and less than a sum. Unknown type name, multiplication C0. I didn't make any multiplication yet. Oh yeah, I have a multiplication here. That is the only way, right? So this is actually the C0 then. Let's call it C0 here. Although it can't be C0, it's a sign, because you can't have a multiplication of a constant with the 0 stands for symbol 0. So it's more like a sine 0. And then this is exponentiation of whatever. It's a sum exponentiation. I need multiple multiplications. So let's make this one. Is 0 constant times the sign of 0. Symbol 0. Yeah, I can also not multiply two symbols. One of them has to be a sign. Let's make or something else. It doesn't really matter, I guess. The first thing that's larger than a product is another multiplication. Let's do 0 with or exponentiation actually. Let's do exponentiation. So now we're missing this one and this one, right? Multiplication. Constant with sign 1. Pick the same constant. I have to define sign 1 as well. And this one is a symbol with an exponentiation. Testsuite. Yeah, bug in the testsuite. Huh, what? Compare equal. I just left that in. Should best be the third fail. Let's stick it anyway. Compare equal, ignore way. So if it is this not equal, this means false. Oh yeah, I didn't finish this code at all. So constant do not compare equal, I have to pass false. And either way, I'm testing that here. And then either way here, I'm testing also the other one. And true then means compare equal. So I get the value for comparing them both ways. E1 first and then E2, or E2 first and then E1, and here as well. Let's just steal the code from here. And then I determine if it should be true or not. The thing is called compare equal, so nothing should be less than. So the value should be false. Then I have two falses. So this one again to be false. And well, here as well. Yep, everything should be false. The one E1 first or E2 first, and then true or false, nothing matters, everything is false. Because they're exactly equal. And then we are printing stuff. It should be false, should be false. So if it is true, then we print an error. Expected E1 to be, well, not to be less, yeah, well, because they're equal. Expected E1 not to be less than E2. And constants do not compare equal. No, let's copy this one for the compare equal. So if should be false is true, then let's print this here as well. That one is okay already, I think. So E1 and E2 to not be less when constant compare equal. Okay, we pass through. And this one is already correct. E2 not to be less than E1. Okay, it says expected symbol 0 to be less than product of a constant times symbol 1. So the idea is that if it is a product of a symbol, product of a constant times something, then a constant is ignored. So this thing should be treated as a symbol. And yes, I agree that symbol 0 should have been less than that. Expected symbol 0 to be less than constant, that's the same error. Printed twice, which is kind of weird. Don't tell me I did the same test twice. Why is it printing twice? Probably because of the either way. But then it should have said when constant do compare equal and one's not equal. Did I miss that? Yeah, I missed that. To compare equal and when constants compare equal and do not compare equal. Okay, that's why it was twice. So apparently what is missing, or what is going wrong, is comparing a symbol with a product that is constant and so on and so on. Yeah, but yeah. Let's see, I commented out a lot of shit, so that could be a reason. Just saying. Yeah, there it is. Symbol comparing with a product. I'll just start with not commenting that out. On the other hand, then I have to do some horrible changes. Make some horrible changes. Because I wanted to know which is responsible for returning true. So I replaced true type with value. But okay, can do that, we can do that. So in this whole block, all the standard true types should be replaced with value type something. Substitute standard true type with slash star standard true type, aka commented out space value type, and then some constants which I have to fill in. Five, 6, 7, 8, 17. Did I miss one? No. 18. 19. 20. 21. 22. Compiles. That's always nice. Okay, this went wrong. Now we see the value of value. First, is it correct? Expected symbol 0 to be less than a constant. Yeah, I don't think so. Oh, not less, sorry. Symbol 0 should be not less than a constant. I agree. No, wait a minute. I'm looking at it wrong. The power, this is a power, sorry. Expected the power of symbol 0 to some constant not to be less than just a constant. Yeah, well, that's okay, obvious. Obvious. Whether or not constants compare equal. So value 7 accidentally picked up the comparison of a power with this constant. Hello. No, I see the power, but it says, yeah, I had that bug before. Well, bug, I mean, it's just absolutely horrible. Please look the other way. That should have been ands instead of ors. It cannot be a constant or a symbol or so. You see the grammar there, the English grammar. It cannot be a constant or a symbol or a power or a product or a multiplication. That's correct English. But we are typing here not, and then parentheses open and ors. No, I did not. So you should say it cannot be a constant, and it cannot be a symbol, and it cannot be a power. I think that's where it came from. Expected symbol 0 not to be less than the multiplication of a constant with the sinus. Value 6. It's a multiplication that begins with a constant, so we should be comparing it with that, but the symbol should always be, wait a minute, not less. Oh, there's an error on my testsuite. It is less. The symbol is less than a sinus. Yeah, the testsuite is wrong. I copied that from product, but it was not allowed to have a multiplication of a constant with a symbol. That's my testsuite. So you can do this for the product. Must be equal if it is a constant. But since it was not allowed to use a constant, so constant times a symbol, I changed it to a sinus. But then it's not equal anymore. Yeah, well, let's compare it anyway, maybe. There's no way you can get the other way around. It's kind of dubious, this test. This test is done really not necessary. That was multiplication. Something. This one, yeah, really also doesn't really. Oh well, actually, this is a constant. Okay, yeah, no, this isn't it. This whole test is, yeah, I don't know. I'll leave it in, but. It's interesting interaction. You have bugs in the code, but you have also bugs in the test suite. And then you hope that they don't cancel each other. And still, it mostly works. Yeah, I think I'm done. We're done with symbol. So, next thing is comparing a power, I think. So a power compares less than anything else except what comes in front of it. Except, no, anything else actually. That comes after it. I mentioned that to be trivial here. So I'm just going to test that it compares equal. What? Power 0 compares equal with itself. Okay, well, accept it so. Actually, that it's way more complicated than that. Let's say anything larger than a power. It compares less than another power if either the ID of the symbol base symbol is less, or the base is the same and the exponent is less. I think that's what we're trying to do here. So obviously it compares equal to itself, and it compares less when the base is different and less. But it should probably try to use a larger exponent in this case. I'm not sure what exponent is here. Power 0 uses a lesser exponent. That's a smaller exponent of the two. Let's explicitly use the larger exponent. Yeah. So it should be less if this is symbol 1. Even though the exponent is larger. And if it is symbol 0, then it should be less if the exponent is less. M1 being less than 2. I think I compared power with itself now in all possible ways. Yep. And then for everything else, a power must be less than, well, anything else. So get kind of the same list as we had here. Product. And then you get the product thing again. Product with a symbol, that's not less. I guess I have to do the same thing as here, those three, but then with a product with a constant in front of it. But I only want to have powers as first on. Power 0 is one of these things. Power 0 is this one, right? This is just power 0. So let's make a power 1. Let's make this power 1. Simple 0, constant 2. Oh, it's 0, 2. Yeah, makes more sense. At least we have 0, 2 now. So that is power 0b. I could call this one power 1. I already did. And this is then not correct. Yeah. So it should not matter if I use a product of a constant with something or that something itself. Power. Okay. Yeah, okay. And then we have compare less of a power and an exponentiation. And then that's where I did a products here. I did products. Sorry, I only did products that start with a constant. To also be less than an arbitrary product. Any arbitrary product? Yes, any arbitrary product. So I can use the product of products. This one. To compare less power 0 with any product. Okay. Then you get multiplication, which is also complex. Let's skip the multiplication for now. Definitely also less than the sign. And it's less than the cosine. And it is less than the sum, any sum, some sum. And then here we have multiplication, which is probably looks a lot like the products, except that some things cannot be done. Yeah, so we have the arbitrary one. So it's less than a multiplication that does not start with a constant. So that would be this one, I guess. But also less than a multiplication that starts with a constant. But yeah, it can't be a product, so it's kind of the same thing as the comparing with the symbol. the symbol's a power to the symbol is just to the power 1, and here it's to some other power, but it doesn't really matter because you can't have a multiplication with a constant and anything that is equal or less than powers or symbols. So I think this list is complete. Then I did not use this one, I think. Can delete them because I'll just type them again if I really need it. Doesn't even compile this time. Substitution into constraint expression resulted in a non-constant expression. While checking constraint satisfaction for class template, partial specialization is less than some ID 0 constant, ID constant false required here. During template argument deduction for class template partial specialization. Exponent is a constant. Two equal exponents. Specialization. Here. Cannot be used in a constant expression. Declaration value cannot be used in a constant expression. That is stupid. I have to figure out something else then. I'm going to remove the operator that I added, constant.h. This doesn't seem not to be needed. It does use something very specific though. I cannot search for that. I think I can use, or should be able to use, is less sum for exponent 1 and exponent 2. Well, value. Comparing them not equal. So there's a constant false. That's this one. Yeah, we're just the same thing. super annoying. It works. Yeah, then we are doing the following. Continue with the thing after the power. Oh, so much. Okay, what do we get after the power? Products. Product. What's the simplest product that I have? What's a product with a constant? I want the simplest product that I have without a constant. This one. So product is less than an exponentiation. And less than multiplication. and less than the sine and the cosine and the sum. Yeah. And then we have to explode these two again, in case they start with a constant. Must be able to do this more easy. I think that the point is it is simply also less than a multiplication of a constant if it compares less than exponentiation, it should also compare less than a multiplication of a constant with an exponentiation. So I guess it should compare equal. I didn't do that up here, right? Actually, I did that way. Product constant times there must be a product. And this case, I'm going to do equal. You see product, so that must be then say a product of a constant with the same thing. And yeah, might as well do this one then. thing that holds. But we're not done, because the product could be a product that starts with a constant, and then all hell breaks loose, because that kind of has to do everything I already did, but then using a product. So all of these, but then a product of a constant with a power. And those. No, not those. Let's first test this. Already fails. Expected. Can't read this, man. Expected product symbol 0, symbol 1 to be less than the exponentiation of, I don't care, yeah, because product is always less than an exponentiation. Twice, with or without constants comparing equal. Yep, okay, so a product with a product and an exponentiation. I could have typed VI. Product with anything. Product with anything that is not a constant, a symbol, a power, or a product. Well, it's an exponentiation, so this should be the one. This compares with a symbol, that's not one, that's an exponentiation, or a power, is also not. Product, is also not. Yep, should have been the first one. Why the hell is this not comparing? Oh, because I'm using E2 here. That should have been E3. And it works. Good. Then we go to the next. So I say that I need to repeat all of these, because they should be less. If I have a product that is the multiplication of a constant with that, and that happens to be symbol 0 all the time. So what is my product with constant times symbol 0? That's probably C0, C1, C0, this one. Some constant times symbol 0. and also the power, and that is a lot of power zeros, but also a few other powers. Do I have a product of a power zero or something? Nope. Well, let's just make it. Or maybe I should instead wrap everything here. Let's wrap everything. Op. Substitute. Less than anything but a comma. Oops. What am I doing here? That one. Anything but a comma. Followed by a comma maybe. Let's replace that with that, and then that. No. And also that one works. Okay, then next we get whatever comes off the product. And exponentiation compares less than anything larger than differentiation. I don't know. Compare exponentiation. Well, let's first do that would be constant times sinus. Well, that's by coincidence, yes. And the other one was easier, or whatever. Exponentiation is less than a multiplication. And it's also less than the sine. And the cosine. And the sum. Well, I have the feeling I'm not having compared everything with the product. I do compare products with products here. So maybe I might have. Yeah, probably I have. Okay, so what about this one? Comparing two exponentiations. is again going on a base and exponent, so it's kind of the same as the power. Those two. Right. This is way too much to compare, man. I don't like it at all. Exponentiations are not allowed to use symbols. So what can I use? The first thing that is larger than a product. Yeah, some multiplication, I guess. Doesn't really matter, does it? That thing, maybe. Okay, so this one should be less than this one, because they have the same base, but the exponent is less. And this one should be less than this one, because the base is less, even though the exponent is larger. So it would also compare less than a product of a constant with any of these factors. But then it's not a product anymore. It could, however, be less than a multiplication of a constant with any of these things. But yeah, it's less than any multiplication anyway. Unless it's a multiplication of a constant with something that is not less. I didn't do multiplications yet, so maybe I just want to have the exponentiation first. So I really only want to compare anything with compare it with anything that it is less than. So it would be a multiplication of a constant with any of these things. And I only have sine is 0, which is this one. But if sine 0 compares less than, then so will cosine and sum, really. I'm still kind of interested though in a multiplication with a constant with an exponentiation. Let's add those as well. Let's even repeat this one. So I do multiplication with a multiplication. Now I can just copy everything, right? So we do differentiation. Yeah, I think I can copy everything. And then wrap these things in a multiplication, substitute, comma, space. Anything but less than. How did I call that? Constant M1, I think. You could call it trivial because it should compare less than a multiplication anyway. But yeah. Oh, I forgot one. Expected an exponentiation of the multiplication of a constant with a sign to the power of that to be less than a multiplication of symbol 0 with an exponentiation. The reason being that any exponentiation is less than any multiplication. This not, because E2 is a multiplication, and this is disallowing with multiplications. All these I use AND everywhere, and NOT everywhere, and E2 everywhere. And this one is also not it, because it's a product, and not exponentiation. There we have it, multiplication. Two, exponentiation is less than a multiplication when E1 is not a constant. Sorry, when E1 is a constant. Oh. No, it's always the case. Doesn't matter if this is a constant or not. This puts exponentiations higher than multiplications. What did I do? No, it should be less. At least whatever the comment says here. I'm not suddenly not so sure about it. Should it be? No, it cannot be. No, it should not. Should not? No, it should not. It should not be always less than. If the multiplication starts with a constant, then yes, I should only look at the second argument. But if it is not a constant, then it should also be less. That's what is missing. So this should be is not a constant. Or it is a constant and it is the exponentiation is less than E2. Less than E2. Yeah, less than E2 if it is a constant. So it's if E1 is not a constant, then the whole thing, the second argument, is a multiplication, and then it is always less than. An exponentiation is just less than a multiplication. Unless the multiplication starts with a constant, in that case I have to compare it with the second argument of the multiplication. So that's kind of a recursive call. Whoopsies. At least it's still exponentiation. Expected exponentiation, multiplication, constant sign. What's your exponentiation? I don't care. Exponentiation to be less than exponentiation. Multiplication, constant sign. Yeah, because there's two exponentiations and the base is less. This is the base, which starts with a constant, so it should be comparing the sign of this symbol with the sign of this symbol, which means that in the end it should be comparing the symbol with the symbol, which is less. So this is about comparing two exponentiations. So that would be this one. One exponentiation is less than the other if the base of one is less than the other. Or, I don't really care, it should already be less. Mistake. The base was less, right? Yeah. But okay, that was a comparison of multiplications and I didn't test it yet. So it can be that the multiplication is not, the base comparison here is not working well. So comparison of this multiplication with the other multiplication. Wish I could find the bag which one this is. Probably the exponentiation of different bases. Should be able to find that back. One of these two. Let's be lazy. If I comment out the second one, does it still fail? Nope. Therefore, it is probably the second one. Yep. Therefore, what goes wrong is comparing the base of these things, and the base of exponentiation OB is this one, and the base of exponentiation 1 is this one. Indeed. Expected multiplication. So this is a multiplication of a constant with a sign to be less than a multiplication of a constant with a sign. Another sign. Yeah, that could be because the sign is not comparing correctly. Guess I should test that first. Otherwise I don't know what I'm looking for. So that multiplication CS0. That's just sine 0, right? Where's my multiplication? This one, so it's sine 0. Sine 0 should be comparing less than sine 1. Or does it? That is the problem. The sign is not comparing less. Okay, so now we can know what we have to look for. I never even added that. It's just completely missing from the equation. Holy shit. So this is supposedly going all the way for multiplications. And then after multiplications I still get sine, cosines and sums. And I have sums here. Some sum is only less than another sum under certain conditions. So the sine and the cosine are missing, theoretically, basically, yes. So the sine of some expression is less than yeah, the way I did that was E2. Saying that E2 can be nothing, including a sign. It's this list, but then with an E2. And also cannot be a sign. Substitute E3 with E2. So E2 is not a constant, not a symbol, not a power, not a product, not an exponentiation, not a multiplication, and not a sign. Then it is less than. Sign is less than that. Correct. And then we have also the possibility that it is a sign and a sign. See what trivial. Make. His sine v is not defined. Do I even have that? Is cos, is sine. Yeah. That works. Okay, let me think. That means that now that should work. I'll add those later. Yeah, now that worked. So I did exponentiation with whatever. I'm not sure I tested everything, but probably enough to test the whole thing. To test everything. Let's test this for fun. And I can delete it if it works. It used to fail. So this is going to test. Ignore the constant. And then the power. Ignore the power. Compare the second multiplication. The sign is then the sign. The sign does it. The sign is compared with the exponent. Exponentiation. This exponentiation is less. So it is actually the other way around, if you ask me. Arc4 is less than, isn't it? I think so. Oh shit. Yeah, no, that's true. No shit. This is definitely true. This sign should be larger arbitrarily than exponentiation, which means that arc4 is less. Oh, wait. They are both. Mark 4 is the last. This is true. This should be false. I didn't know that yet, so I had not typed any exclamation mark. No, that worked. Cool. Just delete this. So next I get multiplication. So much work. Why am I not eating? I should go eat something. Yeah, it's like way late, man. Like hours and hours past the time that I should have eaten something. Because this is gonna take another hour at least, if not 2. I'll be back later. I love you guys. Keep working unless you have to eat, okay? Or sleep.